In 2001, academician Tong Zhu found that glacier winds transport ozone downslope, creating extremely high ozone levels in the Qomolangma region. External input may be one of the main drivers of ozone variation in this region. If we could leave the ground and directly measure the high-altitude glacier wind transport process, then we could further test the scientific hypothesis. However, ultra-high-altitude drone measurements remain a major technical challenge. After payload development, calibration, and integration, DJI's latest drone was ready for the first field observation test. In May 2026, DJI joined the Second Tibetan Plateau scientific expedition and Professor Tong Zhu's team from Peking University to map glacier winds and ozone over Mount Qomolangma. Taking off from Qomolangma Base Camp at an altitude of 5,200 meters, they conducted a data collection mission using a drone carrying scientific instruments. Our goal is to verify that our atmospheric observation instruments can be carried by the DJI drone for high-altitude measurements. Glacier winds flow from the upper slopes of Qomolangma down the valleys. We want to understand how they affect ozone, black carbon, and other atmospheric pollutants. Early in the project, we were looking for a hybrid VTOL aircraft capable of fixed-wing flight. It creates less airflow disturbance, making it better suited for atmospheric sampling. DJI's new drone turned out to meet those research requirements. Its flight performance, payload capacity, available space, and sensing capability all meet the needs of our scientific mission. We planned 2 flight routes. One follows the river valley from upstream to downstream. The other climbs in a spiral to higher altitude. Combining data from both routes allows us to build a 3D map of ozone and other pollutants, helping scientists measure the intensity and spatial distribution of glacier wind transport. Zhangbo, today's horizontal flight, will cover 4 altitudes: 100, 400, 700, and 1,000 meters above ground level. During the first mission, the drone will fly 15 kilometers along the Rongbuk Valley, measuring how ozone concentrations change downstream and helping determine the extent of the glacier wind's influence. Ready? Okay, starting the motors. The DJI EV50 takes off to 100 meters above ground and enters the aerial runway. It accelerates until reaching fixed-wing speed and completes the transition. Fixed-wing mode, combining multi-copter and fixed-wing flight. The aircraft offers flexible takeoff and landing while maintaining the efficiency of fixed-wing flight. It is climbing. Yes, keep climbing. What's the altitude now? 800 meters. You can begin descending. After removing the instrument from the aircraft, we found it remained very stable throughout the flight. That's another important step forward. The horizontal survey was successfully completed, giving the team great confidence. The next day, they moved on to the vertical ascent mission. Today's objective is simple: carry the atmospheric instruments as high as possible. To reach 8,848 meters, the aircraft must withstand low temperatures, turbulence, thin air, and other extreme conditions. No DJI drone had ever flown this high before. This scientific expedition gives us the opportunity to take our instruments higher than ever before. Good. Ready. Take off. I'll monitor the airspeed. You watch the power. Good. Maintain this climb rate. We just encountered a downdraft. Reaching 8,800 meters on this flight may be difficult. 7,000 meters. Battery at 61%. Keep climbing. 7,500 meters. Check the temperature. Next, adjust the target airspeed at 8,000 meters. Power looks good. Keep climbing. Good. Only 800 meters to go. We're already at 8,000 meters. Stay calm. Good. 8,500 meters. Wind speed is now 10 meters per second. Power looks good. Battery looks good. Battery is still at 48%. I can already see the Rongbuk Glacier. I can see Advanced Base Camp. Last 100 meters. 80 meters. 70 meters. 60 meters. 50 meters. Last 40 meters. 30 meters. 20 meters. 10 meters. We've made it. 8,850 meters. 8,854. Maintain level flight. 8,861. Wow, it's beautiful. Incredible. How's the instrument data? There's slight fluctuations, but overall it looks very good. No obvious change in concentration. Excellent. Good. Impressive. Amazing. At first, we weren't sure the drone could fly above 8,848 meters. But today it performed remarkably well. We achieved our goal. Since 2001, when Professor Zhu discovered in the Qomolangma region the mechanism by which glacier winds transport ozone, it was not until 2022 that we were finally able to use a helicopter to complete the first observation of ozone concentrations at different altitudes and their vertical distribution. Now, through this collaboration with DJI, I feel we have taken another step forward in completing a more refined characterization of ozone distribution at higher altitudes. This can also help us further identify the exact pathways of ozone transport. This time we also carried many other particulate matter instruments. This was also a major breakthrough. We are also very glad to collaborate with DJI this time, to do something so meaningful together.